Good morning, everybody. Today we are going to officially start the notes for Chapter 9. I know you guys have been doing a couple of introductory lessons and just kind of experimenting with lines of best fit and correlation and stuff like that. But today we're going to actually start the chapter. You'll take some notes, you'll do some practice problems, and then that'll be it for today. So with correlation, we are going to focus on linear correlation. So if we were to plot our different data points, we have an independent and dependent variables. And once we plot these points, is there a linear relationship? Is our line of best fit? Can we draw a line of best fit? If we can, is it positive? Is it negative? Do we have no correlation? Do we have a correlation that maybe isn't linear? And that's what we're going to talk about today. So a negative correlation shows a tendency that as x increases, so as we go to the right on our x values, our y values decrease. So if we were to draw our line of best fit, it would probably look something like this, and that is a line with a negative slope. Okay, a positive linear correlation says that as we move to the right, as our x increases, our y's also increase. And when we draw that line of best fit, it would be a line with a positive slope. No correlation pretty much is self-explanatory. You can't draw a line of best fit. There's nothing that would work. The data is just kind of scattered all over the place with no trend. It's not trending in any direction. It's not trending up. It's not trending down. It's not doing anything, okay? And then a non-linear correlation. We see a pattern appearing, but the line of best fit, or I should say the graph of best fit, isn't necessarily linear. So in this case, you can see we start as our x increases, our y's increase, and then it changes. And as our x's continue to increase, our y's decrease. So it goes from increasing to decreasing. And this almost appears as if it's a quadratic. So it could take on, the graph of best fit could take on the form of a different kind of equation. So in this case, it would be a parabola, a quadratic. It could look cubic. It could look like anything else other than our just linear graph. Okay, we're not going to focus so much on this. We're going to stay with linear relationships, but just know that that is a possibility. If you were to ask what kind of relationship this is, you could just say nonlinear, whereas this one over here is no correlation whatsoever, and then this one would be nonlinear. Okay, so you guys have used scatterplots in the past, probably in algebra or algebra 2, but a scatterplot is what we can use to determine whether a linear correlation exists between two variables. So basically what you do is we create our grid, and this one's already done for us, but I'm going to list out the steps now. Create your grid, and then you're going to label your axes, okay? And then you're going to plot your data, and then you're going to interpret. All right, so this one's done for us already. Okay, and when we interpret, we want to look for line of best fit. So look for the correlation, line of best fit. And then you want to make a statement. In context of the problem. Okay. All right. So this one, we don't have any context here. It's just kind of a graph with numbers. There's no labels. There's no axes. We don't know what the values represent. But we could see that this one, we would have a positive correlation. We can draw our line of best fit, would probably look something like that. And we would say as x increases, y tends to increase, okay? And we would say that that is a positive linear correlation. right? Okay. So now we're going to go through these two examples, and then you guys are going to do the other two for your practice. So I'm just going to go through and highlight so that we know what to label our axes as. An economist wants to determine whether there is a linear relationship between a country's gross domestic product, also known as the GDP, and carbon dioxide CO2 emissions. The data are shown in the table. Display the data in a scatter plot and determine whether there appears to be a positive, negative, or no linear correlation. Okay, so first we need to label our axes. So our X is going to be GDP in trillions of dollars. Okay, and then our Y is going to be CO2 emissions. And then we also have to put the unit of measure in millions of metric tons. All right, so next we need to obviously put our values on our X and Y axis. So let's start with our X. I always look for the smallest and the largest and put a dot next to them so I know how high I need to go. So we've got 0.8 and 5.9. Now you want to do your best to fill up the entire length of the axis. You don't want to end it like here. Okay, you want to fill up the whole thing. So, you know, we basically have to go from 0 to 6. So we'll go 1, 2, 3, 4, 5, 6. And then I'm actually going to go through and put the halves in as well, because that just helps me. You don't have to do that. So we've got 1, 2, 3, 4, 5, and 6. Okay. All right. Next, let's see. Our lowest amount is 253, and our highest is 1180.6. So that's a pretty big jump. We could probably go by 200s. So we've got 200, 400, 600, 800, 1,000, 1,200. 200, 400, 600, 800, 1,000, 1,200. And again, I'm just going to put the little ones in between them, but I'm not going to label them. Okay, so that's good. We've got some even intervals going on. It takes up the whole graph. It looks nice. All right, so now we just have to do our best to plot. And obviously, you're not going to be able to do it exact, but you want to be as close as possible. So 1.7 and 552 would probably be somewhere around here. 1.2 and 462. 1.2, 462. 2.5, 475. Okay, 2.8 and 375. So 2.8 is almost at 3. 375 would be almost 400. 3.6 and 748. 2.2 and then basically 400. And then we have 0.8 and 253. We have 1.5 and 318. We have 2.4 and pretty much almost 400. Those are really close. Oh no, sorry, that should be almost 500. 2.4 and then almost 500 is right here. And then we've got 5.9, which is pretty much almost 6, and almost 1,200. So So that would be somewhere up here. Okay. So the question is now, if we were to draw a line of best fit, would we be able to draw a positive or negative line? And the answer is yes. It's pretty obvious that the trend occurs as we move further to the right on the x values, our y values increase. Now, again, it's just a trend. It's in general. I know it's not the case for every single point, but that would be the trend. So our line of best fit would probably look something like that, okay? Goes through a good amount of the points, and then the rest are fairly close. So our correlation would be that this is a positive linear correlation, okay? And our interpretation as, and we're not going to say the x's, as the GDP increases, the CO2 emissions tend to increase. Okay, so positive would be as whatever the x value increases, the y value also increases. All right, so that's the first one. Next one. All right, let's see. We've got student conducts a study to determine whether there is a linear relationship between the number of hours a student exercises each week and the student's GPA. All right, so GPA, pretty easy to graph, 0 to 4. So we've got 1, 2, 3, 4, and again, I'm just going to go through and do the halves. So we've got GPA, and the number of hours of exercise per week, it looks like we're going from 0 to 18. So I am just going to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. And then this is the number of hours of exercise per week. Okay, let's get to graphing. So 12 hours of exercise yields a 3.6 GPA. 3 hours of exercise, we've got a 4.0. 0 hours of exercise, we've got a 3.9. And yes, you could put it right on the y-axis, that's fine. 6 hours of exercise, we've got a 2.5. 10 hours of exercise, we have a 2.4. 2 hours of exercise, we have a 2.2. 18 hours of exercise, we have a 3.7. 14 hours of exercise, we have a 3.0. 15 hours of exercise, we have a 1.8. And 5 hours of exercise, we have a 3.1. Okay, so if I were to try to draw a line of best fit here, I wouldn't really be able to do it. As our number of hours of exercise per week increases, as our values on the x-axis move to the right, it's not obvious if our y's move up or down. There's not really a linear relationship. So we would say that there is no linear correlation. And then our interpretation would be the number of hours a student exercises per week does not appear to be related to to the student's GPA. And then you're done. Okay. All right, so you guys are going to do the 2 examples attached to the set of notes. You just have to submit the assignment. You don't have to submit your notes. Make sure you upload it as a PDF. Other than that, have a lovely weekend.